A very warm welcome to you. It's lovely to have you among us. Our today's presentation will be about how science works. I would like to start with a quote from Professor Feynman. Nature permits us to calculate only probabilities, yet science has not collapsed. That means that only because nothing can be proven to be the final truth, the scientific method itself still works. And yes, everything in science is just a theory, the best we know, until we find out more and know better. Most of the things in this presentation is from the chapter How Science Works from the book Weaponized Lies, How to Think Critically in the Post-Truth Era by Daniel Joseph Levitin, an American-Canadian cognitive psychologist, neuroscientist, writer, musician and record producer. Weaponizing Lies is basically the reworked second edition of his international bestsellers, A Field Guide to Lies, extended to take into account recent developments in the field of disinformation campaigns. If you want to learn more about the common disinformation tricks of science deniers, Google FLICC, an acronym that stands for Fake Experts, Logical Fallacies, Impossible Expectations, Cherry Picking and Conspiracy Theories. But how is it possible that we are so easily misled? The answer seems very simple and logical. We and our brains have evolved in and for an environment like this, not like this. We find it difficult to deal with complex interrelationships and intuitively cannot assess probabilities correctly. The importance of science and scientific thinking cannot be overestimated. Today, most of us do not believe that the Earth is in the center of the universe. We can build motors and machines, fly around the globe, edit genes, and even do this presentation on a computer via the internet. So it all starts with deduction and induction, pure logic. Everyone who thinks about how to solve problems in a formal way has run across the concept of deductive and inductive reasoning. Both deduction and induction help us navigate real-world problems, such as who committed a crime, the most likely cause of an accident, or how many planets might contain life in the Milky Way galaxy. But while they are both practical tools for practical problems, they approach problem solving in opposite ways. So deduction is idea first, followed by observation and a conclusion. Induction is observation first, followed by an idea that could explain what's been seen. The other big difference is that deduction's conclusions are bulletproof, assuming you don't make a mistake along the way, and the conclusions are always true as long as the premises are true. So this third sentence is absolutely true because the first two sentences are true. With induction, you don't get absolute certainty. The quality of the idea or the model or the theory depends on the quality of the observations and analysis. This only works if you correctly apply the rules. They are typically taught in philosophy or math class on formal logic. So formal logic can take some time to master because, as with many forms of reasoning, our intuitions fail us. In logic, as a running race, order matters. When evidence is offered to support a statement, these combined statements take on a special status, what logicians call an argument. The evidence can be one or more statements or premises. A statement without evidence or without a conclusion is not an argument in the sense of the word. This is closely related to how scientists talk about the results of experiments, which are kind of an argument, again in two parts, hypothesis and implication. Like in this example, the hypothesis says there are no black swans. And the implication is, if the hypothesis is true, then neither I nor anyone else will ever see a black swan. But the implication is not true. My uncle Ernie saw a black swan and then took me to see it too. Therefore, reject the hypothesis. So, if the implication is not true, therefore the hypothesis is false. Sadly, science is often not as simple as that. For an example, if I have a bag of many coins and I've pulled out 10 at random and they all have been pennies, we could assume that this is probably a bag full of pennies. This gives some measure of support for the argument that the bag only has pennies in it, but not complete support like we see in deduction. We could pull out 100 coins at random to get even stronger evidence, but we cannot prove until we have pulled out the last coin. In the real world, it's often impossible to look at every coin, because there are too many or we cannot see or reach some of them. But like the quote from Professor Feynman in the beginning suggests, science still works. I will end now with a quote of Richard Dawkins, and if you don't know this man, do your research. Thank you.
It works. Planes fly, cars drive, computers compute.
It's an inductive argument.
If you base medicine on science, you cure people. If you base the design of planes on science, they fly. If you base the design of rockets on science, they reach the moon. It works, bitches.